Welcome everyone to Esri Eastern Africa's webinar series. My name is Labandungo, and today we shall be taking a look at an overview of analysis using ArcGIS Pro. Thank you for joining us. Our agenda today is as follows. First, we're going to discuss what analysis is, and then we're going to get into analysis in ArcGIS Pro while taking into account the dimensionality of the data that we are working in. That means we'll be looking at spatial analysis or 2D, elevation analysis while taking a look at elevation, it's 3D, and temporal analysis, which is 4D. Also going to look at the types of analysis that are available within the software, which is proximity and overlay analysis, raster analysis, network analysis, statistical analysis, temporal analysis, 3D analysis, and imagery analysis. We're also going to discuss briefly about charts, and we're also going to discuss about automating analysis using Python. Finally, we're going to discuss extending analysis with Python and R. So before we get into discussing all these types of analysis, let's recap what we know about ArcGIS Pro. So ArcGIS Pro is the newest and the desktop set of components for ArcGIS. So a lot of us are familiar with ArcMap, ArcCatalog, ArcScene, and ArcGlobe. Well, ArcGIS Pro is the new 64-bit generation of desktop software for ArcGIS, and is the premier software that we'd like our clients to use for the future. And it's actually a good sort of what can I say, evolution of desktop software. And basically, this is where you'll be doing all your GIS desktop work or your hardcore analysis. I hope some of you have started using it, and if not, I hope that this session will encourage you to have a look at it and try it out for yourself. So let's discuss what analysis and geoprocessing are. Analysis is basically the transformation of raw data into information or knowledge. Therefore, it follows that spatial analysis is basically the same thing as analysis, except you're doing this for geographic or spatial data. Now, geoprocessing is the rich suite of tools and or framework for processing geographic data. Now, it basically encompasses tools such as those used in data management, data conversion, or data analysis. So analysis is basically done using tools. As you can see at the bottom there, you have a toolbox right there. Though a lot of us may be familiar with particular tools, in case you need a wizard type workflow, ArcGIS Pro also provides for that. As you can see on the right, with a network analysis wizard, a geostatistical wizard, and a business analysis wizard. Now, ArcGIS Pro has 1,500 total geoprocessing tools, with 80 new additions and more being added by the quarter. So let's have a look. Let's jump right into the different types of analysis. And we are going to start off with proximity or overlay analysis. So this is basically a fundamental type of analysis and can be found within the analysis tools toolbox. As you can see, it encompasses a bunch of tools such as extract, overlay, proximity, and so on and so forth. So they found, as mentioned, they're found in the analysis toolbox, and they're tools for extraction, proximity, and overlay analysis. So the following are basically some of the tools that you'll find within this particular set of analysis tools, which is a clip, intersect, union, spatial join, and so on and so forth, up to even including new analysis tools, such as counting overlapping features. So at the bottom here, we can see some examples of proximity or overlay tools. Starting from the left, we can see an example of a buffer tool in use. In the middle, we can see an example of the rings created by the buffer tool being intersected with a polygon layer underneath to give a new type of feature. And on the extreme right, we can see an example of the counting of overlapping features, something we're going to get into in a few minutes. So let's move into raster analysis. And raster analysis is basically fulfilling the same concepts as proximity and overlay, except this time with raster data. So the tools for raster analysis exist in the Spatial Analyst toolbox and require the Spatial Analyst extension. As mentioned before, these are tools that enable you to do spatial modeling and analysis for raster data. And which tools can we find within this particular tool set? It's basically things like distance, density, interpolation, hydrology, things like suitability modeling, trying to find out which is the best location for a particular facility, or using raster data to combine multiple sources of information to find the best region that satisfies a particular requirement. So for example, you can see here in the picture below, we have a diagram of our watersheds based on different elevation models, or a map of crime density showing a basic density map showing where the crime is actually being conducted in a particular region. So to give a better understanding of the types of analysis that we've discussed, let's head into a demo, and we're going to be talking about how to use the count overlapping features tool. We're also going to have a look at kernel density. Basically, questions we're going to be answering are the following. Where are the current facilities located? In this case, we're going to be looking at hospitals or health centers in an area of Uganda called Kabon. We want to find out where the health facilities are located. We want to find out which facilities are people close to, and find out which areas get the most service and where the highest concentration of people are. So without much further ado, let's get into the demo. All right, let's get started with the first demo. In this demo, we'll be concentrating on an area of Uganda known as Kabon. Move into Kabon, and we have some data sets such as the health centers in Kabon. We have the villages. The villages have certain attribute data attached to them. So you can see here the name, village, and so on, so forth, the area, and also some details of occupation and household. So according to certain criteria have been presented to us, a health center is supposed to serve a radius of 10 kilometers around it. So let's see for each one of the health in this area, the area that they cover, which is a 10-kilometer radius. We can do that easily by using the proximity tool, buffer tool. So to do that, we go to the analysis window, click on tools, and the good thing about ArcGIS Pro is you're able to tell your favorite tools to use, and you can see I have the buffer tool here. But alternatively, I could actually just type in buffer and buffer tool, and I get parameters. I'm going to key in my parameters. My parameters are the health centers, and I want to pick radius of linear unit radius is kilometers, and 10 kilometers. I have the choice to make it a planar shape preserving method. I'll probably go for that. If you don't wish to dissolve, so I can actually go ahead and run that. I actually did that a few minutes before, prior to this. You can see I have a health center puzzle, 10 kilometers, and you can see what that looks like. So you can see each hospital, the radius that they cover. So we're just going to zoom in a bit. You can see just looking at this particular detail, you can see that this area around here seems to be very, very distant, because the radius of the health centers seems to cover a lot of the area around this region over here. whereas this region like this seems to only cater for one village. So to see like an exact amount of for example, if you were placed in any one of these areas, how many facilities you'd have access to, you can use a new tool on ArcGIS Pro known as count overlapping features. These are really interesting pane as you type. The tools arrange themselves. See the count overlapping features over here. Click on it, and I can fill in the parameters. I'll go ahead and fill in parameters. Now, in this case, would be my buffer zone, and I would create a new feature class. It gives me overlapping features. That's it's pretty easy. Go ahead and run. Now, running that again, I've run that beforehand, and you can see I have overlap here. So what's really cool about this tool is that it actually gives you a count the number of overlaps that have happened within these features. So you can see if anyone is within this region, they actually have 14. They have less than or equal to 14 health centers at their disposal. So if you're living around this area over here, pretty covered. You have at least 14 facilities that you can visit. Whereas, as you can see, people who are around here that deal with between 1 and 3 facilities. So let's see if now that we have this sort of understanding of the facilities and the villages around them, let's see if these health centers are serving the nearest the people that they ought to be serving in terms of distance. That means that well, if I were to be in a particular point in this region, say at this point where my cursor is, which would be the nearest facility, and is that facility being, is that that village or the point where someone is being served by the nearest facility. So how you do that is by creating what we call a Thyssen polygon. So Thyssen polygon will basically create polygons around the health center, and the polygon will cover the area, an area at which any point within that polygon is nearest to the health center than any point outside. So in that way, the polygons that cover the health centers will represent the area that should actually be covered by a health center. So let's see if some villages fall outside of that. Maybe that's something we could rectify. So we're going to go ahead once again. Easy. Type in create Thyssen polygons. And once again, very easy procedure. Pick in my health centers. And we're going to output our fields with OpenPP ID, or it actually have fields. So once again, easy execute by running the tool at the bottom here. And actually had taken the liberty of doing that earlier. So I have can see the polygon right here. So I'm going to uncheck something you've done earlier. Because you can see, for example, this health facility, which actually works because you can see within the radius and in the polygon. So this gives an idea of the villages that should be serviced by the health centers around them. So anything within this polygon should be served by this particular health center, mostly because it's the nearest health center. So that should tell us something, because you can see over here, this would actually be attached to this as opposed to something like this, which we think is near. Anyway, so within this data set, within the village data set, we actually have the preferred health center people attend. So what we're going to go ahead and do is we're going to create what we're calling spider lines between the health centers and the villages that show their preference for that health center. So we actually have a custom tool here, and that's the spider diagram. Running that actually now gives us parameters. You can have an origin point. Origin point will be the health centers in Gabon. Your origin key field will be the name, the health center. The destination point will be the actual villages, and your destination key field will be what is similar to the origin point key field, which is the name once again. And now we'll get an output of spider lines from the health centers to the Gabon villages. Once again, you can just run that. I've actually taken the liberty of doing that earlier, and this is the result. So I've actually styled it different. Tell. As you can see, most of the health centers are serving the facilities that are within the range that they're supposed to serve. However, you can see some discrepancies here. Like this health center is actually serving people who are well outside their region. They actually have to travel a long way to come to the health center. And see the same here for this particular health center, serving some people outside. As with this one and this, see a bunch of them outside. But for the most part, every village is serving, every health center is serving the villages that are within its the nearest distance. So that actually works out really well for this particular area. Maybe somebody needs to look into creating a health center around this area that these people don't have to be. So once we've done this, you might want to, you might be the market of trying to find out where people are found. Much people are found, but mostly where people are dense. That sounds very funny. What I mean to say is where there's a high density of people within this particular region. And we can actually do that quite easily by using symbology. I'm going to uncheck this nearest distance, spider lines, as well as the health centers. And I'm going to do that using the symbology tab. So I have my Gabon villages here. I'm going to come to my appearance tab at the top. And under symbology, I'm going to pick heat map. Now immediately, this actually takes in is able to create a heat map using the density of the villages. However, each of my villages has a population component. So I actually want to use the population component, the density of the people. So how I'm going to do that is actually come to the weight field, and in the weight, I'm going to put in my population 10. So first we're going to get that, but instead I'm going to use a dynamic density definition. And as you can see, now we have much better, much more reliable idea of what the density is. So this is a form of smart mapping, which ArcGIS Pro uses. So that means as you zoom in, it actually tries and recalculate. You can see as I zoom in, it actually recalculates itself and redraws. However, you might want to have a raster data set, this particular information. So at the top right, the symbology tab, we have what we call a burger button. And clicking on the burger button allows us to use the symbology created here, the heat map symbology. We can convert that to a static raster. So clicking on a static raster actually opens this window, which we call the kernel density. And for anyone who might not know what kernel density is, there's a really good information tab here. It basically calculates a magnitude per unit. from a point feature using the kernel function to fit a smoothly tapered surface. So we're going to use this to create a raster dataset. You can see it picks up the weight of what I used as the population field. I don't have to worry about this. Any one of these parameters, I can go ahead and actually run it. So once again, I had actually taken the liberty of doing that earlier. So we're going to uncheck this and actually check kernel density, use difference technology. Yeah, exactly. Now we actually have a raster data set that fits the bill of that shows us the density of this particular area. But it's pretty dense around here, and patches of population around. So within this demo, we've been able to do a number of things. We've been able to starting from the back, moving towards starting from where we left off to where we started. We've been able to create a raster surface of the population density within this area. Before that, we were able to find out which facilities are within the range of service, of which villages are within the range of service, the acceptable range of service within a particular facility, and we're able to see which areas get the most service, which is what we're able to do using the count overlapping features tool. So having done that, let's go back to our slides and continue looking at the types of analysis. Next up, we have a network analysis, and these are basically tools that are used to analyze transportation networks. So for you to make use of these tools, you're required to have the network analyst extension for ArcGIS Pro, and you can actually make use of these tools through a wizard, as you can see from the top, the network analysis wizard, or you can go straight ahead to the network analyst tools and make use of the tools from that particular section. Now, which tools are we talking about? We're talking about tools like service areas, tools that allow you to do routing between two particular locations, tools that allow you to find the closest facility next to a particular incident, or even something like a location allocation problem where you need to assign facilities to demand points, or an origin destination cost matrix, find out the least cost path between two particular locations, and basically solving things like routing problems and creating network datasets. As you can see from the picture below, this even extends to 3D models in such a way that you're able to do things like 3D routing. So with that in mind, let's jump into another demo and let's see how we can implement things like service areas or finding out closest facilities and answering questions such as which areas are closest to a facility or which particular health centers fulfill a minimum distance rule or are closest to a particular location. So let's get right into that. So let's get into demo 2, where we'll be using or exploring network analyst tools, and we're going to be utilizing service area tools and accessibility tools. And the 3 questions we're going to be asking, trying to solve in this particular demonstration are: which areas are closest to the facility, which villages fulfill the minimum distance rule, and which facility is closest to a particular location. So we kick-started from where we left off, from demo 1. We have our health centers and our villages, and based on some criteria that we've been given, it is desirable that villages be a 15-minute drive from where the health centers were. So for us to find out which villages fulfill this requirement, we're going to make use of network analyst tools. The one that we're going to make use of to start with is service areas. So we're going to use the network analysis wizard. You can see here we have a network analyst wizard. I'm going to click on it, and I'm going to be presented with several options for network analysis. And what I want are the generation of drive time polygons. So on clicking the service area, I'm going to be presented with a new analysis layer. And you can see the network location or the network dataset that's being utilized is from ArcGIS.com, meaning that it's from ArcGIS Online. So most likely this operation is going to consume credits from the organization that I belong to. It's actually going to create a whole new layer that relies on the dataset, network dataset from ArcGIS Online. You can see that it's actually created a network dataset with points, with facilities, point barriers, lines, and so on and so forth. And you'll also notice that at the top and on the tabs, you can see that as has been mentioned in many previous webinars, ArcGIS Pro is a very interactive, intuitive type of software. So immediately my service area is created. You can see an extra tab has been created named service area and a tab named network analysis. I'm going to actually click on the service area and I'm going to import facilities into my service area layer. So the facilities that we're importing are actually the health center. I'm going to pick my health center. I'm going to go ahead and run this. So by doing so, I'll be importing my the features within my feature class, that's the health centers, into the service area so that you participate in network analysis. As you can see, you'll notice, let me just check the facilities are actually, what you see as facilities now are actually where my health center are. So what we need to do right now is create a service area, and we're going to use the tool, this service area tool right here. And I'm going to be looking at driving towards the facility. So let's say if somebody's sick in a particular village, I want to drive towards there. And I'm going to have the following cutoffs. I'm going to start off with 15 minutes. And we're going to contrast it with something else, 25 minutes. So we'll have two rings. We'll have a ring that shows a drive time of 15 minutes around a particular facility, and one for 25, just to see, compare the two. I'm not going to go for standard precision. I'm just going to pick a generalized precision. Then I'm going to go ahead and run the network analysis to solve the active network analysis there, which involves my facility which I have. So as you can see, it's actually solving the analysis layer and it's making use of my network analysis and dataset from ArcGIS Online. So what do I expect from this particular tool? What I expect from this tool are polygons that show the drive time, the area that can be covered from when you're driving towards the facility in 15 minutes and in 25 minutes. And I expect them in separate rates. As I can see, it succeeded. And so what I'm expecting now is for it to draw on my map interface. Now, even though I've used ArcGIS Online right now, you can actually create your own network dataset and utilize a local dataset. You do not always have to use this one. So I just thought I'd mention that. But we don't make the assumption that you always need to be on ArcGIS Online for this to work. I've only used ArcGIS Online for convenient. The layers drawing out terms. So there we have it. We have the layers drawn out. You see right here. We have our polygons, 15. The lighter green shade is the 15-minute drive, and the darker is the 25 drive. Now, I'm going to make a selection for the 15-minute drive. I'm actually going to use select by attributes. My input will be polygons, which new expression, and my tool break will be 15. So that means the 15 minutes drive time. So go ahead and run. You can see that selected that. Now I can actually extract these and have my separate polygon layer outside this particular service layer. So I did that a bit earlier. So to check that and actually check that, actually go ahead and check 15 minute drive actually created. So now we have the drive time, we have the areas that are 15 minutes, a 15-minute drive away from the facilities in which they some facilities which serve them and their population. So what we can do now is actually extract the villages that fulfill this requirement. And we can do that by using the intersect tool. So we once again go back to our proximity analysis tool, intersect, and our input features in this case will now be the carbon villages, and it could be the villages that intersect with our 15-minute drive. So once we run this, we'll be able to find our the villages that are available, that whose particular facility is available to them via a 15-minute drive. Once I run this tool, which I had run prior to this, actually get my villages right there. I mean, my villages right there. And I'm going to, purposes of visualization, I'm going to check the other health centers and 15-minute drive. All the villages. So these are the villages which fulfill that criteria. They're the villages in which you only need a 15-minute drive to get to your facility. So using that quick demo, we've been able to find out which facilities meet that particular area. And as we close up on the demo for network analysis tools, we're going to find out for any particular facility inside here. Let's find out which the closest facility for any one of these. I'm going to pick a particular facility. I'm going to pick this particular facility right here, and we're going to find out the closest facilities to it. 3 of the closest facilities. So once again, going to find the closest facilities. You can see I have find closest facilities, ready to use tools. We're going to talk about ready to use tools in the slides very soon. As you can see, this one still uses ArcGIS Online, so this tool consumes credits. I was going to go ahead and pick an incident. So my incident is actually, instead of picking from the layers, I'm actually going to create an incident. I'm going to create a point by clicking on this edit button. I'm going to create my point here at this particular village. So I'm actually situated at this particular village. The facilities that I'm looking for are my health centers. And I'm going to go ahead and I want to find 3 facilities that are close to the particular place I've picked. The analysis regions within Middle East and Africa. And the travel direction I'm looking for is from my incident to the facility. I'm going to go ahead and run particular tool. So running this tool is actually going to give me some outputs. It's going to give me output routes It will give me output facilities, output incidences, and output directions. So I'll get directions to the facility, I'll get the routes. So I'll be able to know which is the closest route and which is the farthest route, the farthest facility and the closest facility, since I'm picking 3 facilities. You can see that, as you can still notice, some other layers are being added here. Output facilities, output incidents, output closest facilities, output directions, and output routes. So you can see my tool completed with warnings. Let's see what the warnings are. So apparently, network elements will avoid restrictions at traversed. So which means basically that my routes, the routes that have been generated, actually move through some of the routes actually move through paved roads. That's not a big issue. Let's go ahead and find out the nearest facility. So I'm going to pick those output routes. I need to open a table. You can see the facility rank. So the closest facility is actually Renge Park Health Center. And the second closest facility is Katile Health Center. Third is Kaped. So clicking on this and actually zooming, you can see that you can see that from the incident, the facility. Let me check the health. You can see I have my health center here. This is where my incident is. The first one is Renge Park Health Center. You can see the total miles, 0.357 miles, 0.57 kilometers, so on and so forth. The minutes that it would take to get there. Same for our second route. The incident to, this is the Katile Health Center. Our second closest facility. And our third closest facility is Kapedo Health. So using network analysis tools, we've been able to using our network analysis tools, we've been able to find out the 3 closest facilities to a particular incident or a particular village where we set up as an incident. And we've been able to make use of the network analysis layers to answer the 3 questions we had in it. So let's go back to our slides and continue looking at different types of analysis. Right, let's get into the statistical tools available in ArcGIS Pro, and we're going to kickstart this with the geostatistical analysis tools. And now these are tools that require you to have the geostatistical analyst extension, and these are basically tools for performing both deterministic and geostatistical interpolation. So what can these tools do? They basically allow you to do things like exploratory spatial data analysis, methods involved in kriging, allowing you to provide sampling or simulations, interpolating, making 3D interpolations, or even providing you with a geostatistical wizard, which is basically a tool, an interactive tool that walks you through the process of modeling the structure of spatial data so that you're able to make predictions. So geostatistical analyst tools are basically tools that allow you to make predictions from discrete data points of a continuous variable. So for example, you've been collecting, you're trying to find out what's the general temperature of a particular place. You take discrete data points of temperature at various locations, and you create what you can call a prediction map or even a standard error map. And the same tools allow you to check the kind of predictions you're making through things like histograms to find out if your data is evenly distributed, or semivariograms, which allow you to see if you've modeled your prediction based on the correct parameters. And the statistical tools continue with spatial statistics tools, and these are found within the spatial statistics tools toolbox. And this is available at all license levels of the software, which means that whether using a basic, standard, or advanced level of the software, you are you have these tools at your discretion. So these tools are made for they're used for performing spatial statistics. And basically, what we're doing with spatial statistics is finding patterns within a geographical constraint. So measuring geographic distributions, finding or doing an analysis of patterns in a particular region, or finding out clusters, and so on and so forth, or even regression, trying to find out the relationship between a dependent variable and one or more independent variables. So examples of these are creating something like a standard deviation or like ellipse, where you're able to find out where the concentration and direction of particular details, particular point features are found. Or also something like a cluster or outlier analysis, trying to find out where particular clusters of information or of data can be found within a particular region. Or let's say something like geographically weighted regression, finding out where, for example, in the diagram, we can see there the areas that are darker are basically for the variable that's being measured. It's the relationship between different independent variables is stronger in the places that are darker than the places that are lighter. Or even something like multivariate clustering. So you're able to find out like okay, based on what you're searching for, what you're trying to analyze, some areas are similar to others within a particular region. And that's what spatial statistics try to solve, or try to bring out bring out visually. Now, when you add the component of time to spatial statistics, then you get space-time analysis. And you find this within the space-time pattern mining tools. So basically, it's the same thing, except this time you're adding a temporal element. So you're still looking for patterns within your data, but this time you have a temporal element. And just like spatial statistics, the toolbox that's in use here is available at all license levels. And as I've mentioned, it's for performing spatial temporal statistics. And these include basically the things that you're able to do on spatial statistics, but this time adding the time element. So emerging hotspot analysis, time series clustering. So it's clustering, but this time time involved. Or even extrapolating that into space-time cubes in both 2D and 3D scenarios. So with that in mind, let's get into a demo that will allow us to see how geostatistical tools can be used within ArcGIS Pro. We're going to look at density clustering and mean center tool. And ideally, what we're trying to answer within this demo is which areas are not being served by the facilities, which is in this case the health centers in Carbon, as well as which are the best areas to situate a new facility. So let's get into the demo and see how that works out. So let's get into the third demo. In this particular demo, we're going to be looking at spatial statistics tools, and in specific, we're going to be looking at density clustering and mean center. And the questions that we're going to be looking to answer are the following. Which areas are not being served by the facilities, and which are the best areas to situate a new facility? Let's dive back into ArcGIS Pro. Following from the previous demo, we were looking for villages that met the criteria of a 15-minute drive to a health center, and we were able to find out and actually point out these facilities. As you can see here, the nearest access 15 minutes. And let me switch off the Carbon villages and the health centers. So these are the ones that fulfill the criteria for a 15-minute drive. So in this particular section, now we're going to be looking for the opposite. We want to find out the villages that don't meet the criteria for a 15-minute drive to a health center. Now we can easily do that by running select by location tool, picking the villages as our input features, and doing an intersect with the 15-minute drive polygon that we created in the previous demo. So running this particular tool will actually give us, and actually inverting the relationship, I have to mention that. So running that tool will actually give us the following selection. And let me check off the rest. Now with this particular selection, now we have features that do not fall into the 15-minute drive polygon. So what we're going to do with this is we're going to try and find out if there's any sort of pattern that emerges in the villages that we've just selected. And if there's a pattern that emerges, we're going to create a cluster of those points based on spatial distribution. And we're going to consider each one of those clusters as a potential area where we can situate a new facility. So let's go right ahead and do that. And we're going to do that using a tool known as density-based clustering. You can see density-based clustering, finding point clusters of point features based on spatial distribution. So once you pick that and you put in your input features as the point features, the villages that are outside the 15-minute drive, we're going to use a particular clustering method known as DB scan. And what's really good about this particular method is that it's able to determine for itself, just by looking at the spatial distribution, what constitutes a cluster and what does not. So the only criteria we'll put in here is that we would prefer that a cluster has more than 5 villages. And any cluster that doesn't meet that criteria, any cluster that doesn't meet that criteria will be regarded as irrelevant. So once we run that tool, so I took the liberty of doing that a bit earlier, and I have this particular set of clusters. So if you notice, here we have a bunch of clusters displayed in different colors. I'm going to uncheck our selection. You can see we have a bunch of clusters represented by different colors. We also have noise. So noise is basically the features that do not form part of any cluster, or the ones that fail to meet the threshold of 5 features per cluster. Something else that's been generated are 2 charts. So we have a distribution of membership probability. When I open this chart, you're able to see the probability, the distribution of features that made a cluster. So as you can see, there's quite a number of features that didn't make any cluster. That's 58. But the rest of these, anything above 0, made a cluster. So anything that had a probability of being in a cluster, around 68 were definite clusters, and the rest had a minor probability of being in a cluster. We also have features per cluster chart, and you'll notice that we have features that have a cluster ID of -1. So features that have a cluster ID of -1 are generally regarded to be noise, or features that don't fulfill the criteria of being in a cluster. So this is a really great way of visualizing your results. Not only does it give you visual results, it also gives you charts and graphs. So let's close this charts and go back to our map. So what we need to do is we need to select the clusters, the actual clusters, and leave out the noise. So we can do that by doing a select by attribute. And what we're going to do is going to do a new selection where our cluster ID is not equal to -1. Go ahead and run that. As you can see, only the actual clusters have been selected. Now, with that in mind, now we know the areas in which their facilities, their closely packed villages, which form a cluster where people are away. They're more than 15 minutes away from a health facility. Now, we have around, just looking at the clusters over here, we have around 1, 2, 3, 4, 5, 8. We have 8 clusters, and therefore we have 8 potential areas in which we can situate a facility to serve many villages. So what we're going to do is we're going to look for these 8 potential areas, 8 potential locations for the facility, and we're going to do that through a simple tool known as the mean center. So let's get back to our geoprocessing tools, and we're going to type in mean center. What the mean center does, it identifies the geographic center for a set of features. So we have 8 clusters. We want to get the centrally placed point where we can put a facility to serve these villages. So we're going to go ahead and run this tool. So we're going to use our input feature class as the density-based clustering. We are going to leave out the weight field, but we're going to classify these particular facilities based on the cluster ID. So each cluster will get a geographical center, which will be a potential place to put in a facility. We're going to go ahead and put in our case field as the cluster ID. And on running this, which I took the liberty of running a bit earlier, we will find we have 8 spots that meet our the mean center of each cluster. You can see for each of the clusters, let me unselect that. You can see for each cluster, we have a mean center. We have something that center that might be able to work for people that are outside of a 15-minute drive. So using 2 of our spatial statistics tools, we've been able to identify potential sites for locating new health centers for the villages that are not served by health centers that are 15 minutes drive away. Now, this is a very high level sort of or basic analysis that we're using. If we want to go deeper into modeling the suitability of every one of these centers, we need to take into account other things like what's the situation, what's the transport situation, what's the density of people around these particular areas, and so on and so forth, as well as the capability of these people to actually move towards this particular health center. The idea within this demo is just to show how the spatial statistics tool works and the logic that one can employ to make use of that. So now that we're done with this demo, let's go back to our slides and finish off talking about other types of analysis and how to automate analysis. Right, let's get into 3D analysis. And these are tools found in the 3D Analyst toolbox that allow you to interact with the 3D data. The tools used in this toolbox make use of the 3D Analyst extension for ArcGIS Pro, and therefore this is something that you need to have if you want to make use of these tools. What do these tools do? These tools are used for working with surface models or 3D vector data. And what do these tools allow you to do? They allow you to create 3D feature relationships, allow you to apply city engine textures to features that you may have extrapolated or created multi-patches from. They allow you to do 3D interpolation, also allow you to get into data management, generating surfaces, and looking at visibility. Naturally, they use datasets such as LiDAR and other datasets that include 3D datasets. So for example, some of the things you can make with the 3D analysis toolset are you're able to create sightlines, so you're able to see in a 3D perspective what items might be obstructing somebody's view at a particular height, or maybe a skyline, which is the same thing, except now you're trying to see what obstructs somebody from seeing the sky in a particular urban setting. You're also able to create things such as a watershed volume, which you can see over here, right here, and also things like a 3D buffer, which is a real life scenario. For example, in this particular image, we can see something that is akin to a power line, and we have a 3D buffer around it. And therefore, using this particular tool set, we're able to see which items might be infringing upon the power lines buffer. So it's basically, it's very real world sort of analysis and gives you an accurate picture of what you'd expect when you set up things in, once again, not to say it too much, the real world. So something else, another set of analysis tools is the GeoAnalytics Desktop. Now, this set of tools need an advanced license level, so you can only use this if you have ArcGIS or Desktop Advanced License. And basically, you'll see that the tools within this tool set are basically tools that we've talked about below. You can see we're talking about analyzing patterns, which is like spatial statistics, or summarizing data, or using proximity, which is proximity overlay tools. Now, the only difference between this and what we saw before is that these tools are used for performing parallel processing using Apache Spark. So Apache Spark is a technology or a framework that allows you to use multiple computing cores to take care of processing jobs. So for example, you might want to do processing, let's say a huge interpolation, create a surface and do interpolation, but it's millions of points. So if you run that on your normal desktop, it will take quite a while. But now, for example, with GeoAnalytics Desktop, and especially so in an enterprise environment, you're able to make use of multiple cores that might be within your network and have the processing done over there and the result brought back to your desktop. So the idea is basically using external resources to do your processing and getting the result on your desktop while not necessarily being on let's say a web platform. You're still on the desktop platform. You just sent out your data to be processed and you get it back. So the GeoAnalytics Desktop analysis tools allow us to do that. Let's go to imagery analysis. And though we've talked a bit about imagery analysis as concerns raster data, so we're going to be talking about image analyst extension. Now, you need image analyst extension to use the imagery analysis tools. And you can see some of the tools that are displayed there in that picture. So they're basically tools for working with imagery and raster data. And they allow us to do things like deep learning or stereo mapping. So where you're able to get overlapping imagery with multiple time captured over multiple time periods, or having at multiple depths or heights, and create a 3D model out of that. Or you're able to do image classification and categorize different pixels based on from a remotely sensed object or image, or even doing image space analysis, which is basically finding patterns within an image, or multi-dimension analysis. So the imagery analysis toolset allows us to do all these things within the ArcGIS Pro framework. We also can't forget charts. So charts allow us to visualize qualitative, quantitative, and temporal data. And whereas, let's say in the statistical field, people are normally accused of leaving out spatial data when giving out their results because they use charts and graphs. In the GIS world, people are normally accused of only presenting map sort of outputs and leaving out charts and graphs. So this is actually a really important capability within ArcGIS Pro, where you're able to provide all these types of charts that we're seeing here. And just like we mentioned before, or even as we've seen in the demo, some of the analysis tools that we use actually have chart outputs. So for example, when you're doing interpolation, or you're doing kriging, you're actually going to get, as part of what you're doing, you're going to get a semi-variogram, or you're going to get a histogram while you're doing your analysis. So Basically, charts are part of the analytical framework of ArcGIS Pro and are some of the outputs that you'll be able to get from the data sets that you're working with. So we also have ready-to-use services or portal analysis tools. And basically, these ready-to-use services are tools that are provided to ArcGIS Pro as a service coming from ArcGIS Online. And therefore, when you use these tools, you actually use ArcGIS Online credits. So you might want to use them sparingly just to conserve credits within your ArcGIS Online organization instance. Now, the portal analysis tools do pretty much the same thing, except they require an ArcGIS Enterprise deployment behind the portal so that you can make use of the tools. The thing about the tools that we're talking about here are they're almost exactly the same tools that you've been working with or we've talked about in previous slides. The same geoprocessing tools, except now provided as a service. So as you can see in the pictorial here, and ready-to-use service tools, you'll see that a majority of the tools offered network analysis, and that's because ArcGIS Online offers the network dataset as a service. However, it also offers other services like a hydrology service or an elevation service that you can make use of. So you can see under portal analysis tools, we have feature analysis and raster analysis. And with items such as raster analysis, you might note that you need an image server extension in the background, as well as an image server role. So actually, that's now the image server extension is now this image server role. So you need an image server role in the backend. And for doing like large amounts of data, working with large amounts of data, you'll need to have a GeoAnalytics server role at the back end so that you're able to do things like analyzing patterns, finding locations, managing your data, and using proximity. So ideally, all these services provided are actually geoprocessing services provided to you on your ArcGIS Pro instance, either coming from ArcGIS Online or ArcGIS Online being the ready-to-use services and portal analysis being powered by an ArcGIS Enterprise deployment in the backend. So for you to use this, you need to have one of those two supporting your ArcGIS Pro instance. Now that we've talked about a number of analysis tools, let's talk about automating analysis. So you may want to do the same. You may want to run a geoprocessing tool, but run it for a large number of features. And instead of running the same tool multiple times, ArcGIS Pro provides functionality for you to do batch processing. So basically, you can run the tool in one go and target very many feature datasets. You might also want to, use tools in quick succession to each other. And one thing that's been there for a while for all of us, for the ones who've been using ArcMap, is ModelBuilder. ModelBuilder is translated directly into ArcGIS Pro. There's no difference. So if you've been using ModelBuilder on ArcMap, you can easily make use of the same in ArcGIS Pro. One really good function that's provided in ArcGIS Pro is that you're able to export the ModelBuilder tool, the tool that you've created using ModelBuilder to a Python script, and you can actually deploy that Python script anywhere where the libraries that you're making use of can be accessed. That means you could run it as a script separately on something else like PyCharm or IDLE or something of that sort, and still have the same output, and not necessarily have to be in an ArcGIS environment. Something that's new on ArcGIS Pro is the ability to schedule geoprocessing. So you want some geoprocessing to be done at a particular time, and this includes whether ArcGIS Pro is open on your desktop or not. So just like we have task scheduler in Windows, you can actually schedule geoprocessing tasks and have them run whenever you want. So you could actually be done with the work that you're doing on the desk and decide to go home and leave something to be scheduled to be geoprocessed at a particular time, day or night, and come in the morning and find the work done. So that's actually part of what we discuss as automating analysis. So these are the formats in which you don't necessarily need to get into too much customization. You can actually set up your model and schedule that to be run without necessarily knowing the ins and outs of of the languages used to write the tools. If you are into extending, or you'd like to use Python with other libraries that are outside ArcGIS, then you're actually able to open the Python window and work with the Python script tools and write your own scripts on that particular section. There's also the capability of adding the Jupyter notebooks onto your ArcGIS Pro installation, and that's through the Insert tab, you're able to add a notebook. So ArcGIS notebooks will basically allow you to write Python scripts right within ArcGIS Pro and be able to communicate with the portal that you've connected to. So for example, if you're working with ArcGIS Pro, licensed to ArcGIS Online, you'll be able to make use of the services on ArcGIS Pro, on the services on ArcGIS Online from within ArcGIS Pro, and at the same time, work with data that is within your desktop. And at the same time, you'll be able to save that notebook and actually send it to someone else, and it should be able to run exactly the way it was running on yours. So ArcGIS Notebooks is actually a really good way of extending analysis with Python, and we're going to have a look at that in a demo in a short while. So let's get into the demo where we're going to discuss automating analysis, and we're going to see how one can get into batch processing. We're also going to see how one can do scheduling of geoprocessing tasks. And finally, we're going to have a quick look at ArcGIS notebooks within ArcGIS. Let's go. Okay, let's get into the final demo of this particular webinar. In this particular demo, we'll be looking at automating analysis, and we'll be looking at the following three methods of doing so. We'll briefly touch on the three of them. Number one is batch processing, scheduling geoprocessing, and ArcGIS notebooks. So let's dive into ArcGIS Pro. And on opening ArcGIS Pro, let's discuss a few things that we did not mention while talking about analysis. So number one is the history button at the analysis tab. The history button allows us to see every tool that we've run in the recent past. So as you can see, I'm able to see what time I ran a particular tool. I'm able to see what date it was actually run, and I can hover over each one of those tasks that were run, and I can see the details of the tasks, including the parameters that were given and the environment in which the tasks were run. So let's also have a look at some of the buttons here. We have the Python window, just like we have the Python window in ArcMap. You're able to execute Python commands using the ArcPy library through this window. The same for the ModelBuilder, which is something that you're very familiar with in ArcMap. It's right the same as it works the same in ArcGIS Pro. You open your ModelBuilder window and pull in your tools, and you're able to create a new tool using ModelBuilder. So let's discuss some of the things that we had mentioned in this slide. So number one is batch processing. So one thing about the tools that we've been using so far, you'll notice that once you click on a particular tool, you're led to, click on a particular tool, you're led to fill in the parameters and run that tool. What if you want to run the same tool for multiple data sets? That would mean that you have to keep opening the buffer window and putting in parameters running. However, there's an easier way to do that. You can actually come to the tool itself and then right click on the tool, and you'll find an option in the context menu to run the tool multiple times. That is the batch tool. And it comes in the form of a task, an ArcGIS Pro task. So you'll put in your batch parameter, and you can actually go ahead and put in your input features. So in this case, I can add one, and see it allows for me to add another and another. That way, I'm able to run the tool once, but affect multiple data sets. So that's an easy way to go about running the same geoprocessing task on many data sets. One other thing about the tools is once you fill in your parameters, for example, let's say carbon villages, and you want to do a buffer, let's say 1 kilometer. Let's say 5 kilometers. Now you can either run this tool now by clicking on the run button, but next to the run button you'll notice that there's a downward pointing arrow, and that allows me to schedule the running of this particular task. So if I click on schedule, then now I have an option to choose the time at which this particular tool will run, and when it starts and when it ends as well. Now the good thing about this is that this also works even if ArcGIS Pro is switched off. So let's say you're done with your work and you close ArcGIS Pro. The task that you schedule to run will run regardless of whether Pro is open or not. And so finally, I'd like to talk about ArcGIS notebooks. And let's talk about notebooks first. So notebooks are basically powered by a framework called Jupyter. So the Jupyter notebooks is basically you being able to execute Python code on a browser and receiving the results within that browser. And now this capability has been brought into ArcGIS Pro. So you're able to add notebooks onto your project, and you can run those notebooks to give you specific results that you might need. So it allows you to run, to import, to work with various libraries that are various known Python libraries, and integrate them with ArcGIS, the ArcPy library. It also allows you to work with the ArcGIS API for Python and connect to portals such as ArcGIS Online or an ArcGIS Enterprise instance. So to add a notebook onto your project, you just need to come to Insert, a new notebook, click on that, gives you a chance to create a notebook. And once your notebook has been created, you can actually now access it from Catalog. You can see I created this new sample IP Iron Python notebook. So opening it, you get interface. So in each one of these cells, you can actually type in a command. So for example, I would say something like import ArcPy. Run that. So that's actually imported ArcPy into our into this particular notebook. I'm going to go ahead and close this, and then go back to the catalog and open an already created Python notebook, which is called project notebook here. As you can see, this one actually has a bunch of code, and we're going to go through the code itself, discuss what it does. So ideally, this particular notebook, running this notebook should give you an implementation of kernel density. So if you remember, we did kernel density in the past demo after we created a heat map of the villages. So we're going to do the same thing using Python. Now, this is the beauty of notebook, is that you're able to use things that you're working with in ArcPy and still also use the ArcGIS API for Python. You can see our first line here is importing ArcPy. Our second line is importing from the ArcGIS API for Python, a library in which you're able to instantiate an instance of ArcGIS Online or portal for ArcGIS. You're able to do a bunch of things, including add libraries that are well known within Python, for example, like pandas and NumPy, as well as add components of ArcPy like spatial analysis. So this is what it means. You're able to load an instance of a portal. You're able to define your working directory. As you can see, my working directory is my default geodatabase. And you can see my default geodatabase over here, my project.gd. I'll go ahead and list layers in your working directory. So the good thing about working with different cells in Notebook is that you're able to run individual cells their own. So for example, if I click here, say run, you'll see that it actually will be able to list my feature classes. Okay, I think my environment workspace has not been determined. So for example, if I picked this and placed it here, and then run my particular cell, I should be able to get my a list of my feature classes within the project view database. So the same applies for wanting to see like the first 3 rows of a particular feature class. So in this case, I've taken my feature class as Kabong, Villages, Spatial Join. I'm able to do that and see the first 3 rows of that particular feature class. Then we get to the meat and potatoes of what we're doing. So what we actually want to do is create a kernel density output for Kabong villages. We're going to weight it using the population field, which is population 2010, just like we did in demo 1. So I'm going to go ahead and dock this so that we're able to see what we're running in Python actually be visible on the map as well. Once we are done with that, we can actually go ahead and run this. So you can see the kernel density has actually been generated. Let me uncheck the couple of pages. You can see here it is. We actually generated the density in that method. You can see the difference is probably the way the cell size are used and the search radius. Now, having done that, you'll notice that once this has been done, if I actually look at the properties of this and look at the source, you can see it's gone to my project.gdb and it has come to the dataset kernel ID carb3. So finally, we can go ahead and save the output. So I want to save it in a particular folder. I have an output folder here, so I'm going to go ahead and delete that. So once I've done that, I can actually go ahead and save the output kernel density. You can see now the density has been saved. So basically what we've been able to do here is we've been able to run an ArcGIS notebook. We've been able to run analysis through ArcGIS notebook, and we've been able to access a portal from ArcGIS Online, and at the same time we've been able to run analysis on a map view within ArcGIS Pro. So with that, let's go back to our slides and finish up the presentation. Finally, while still keeping with our theme of extending analysis in ArcGIS Pro, let's discuss extending analysis with R, which is a well-known statistical computing language. So extending analysis in ArcGIS Pro with R is made possible through the use of a tool called the ArcGIS Bridge. So the ArcGIS Bridge has 3 scenarios which you can use to enable analysis with R in ArcGIS Pro. So the first scenario involves ArcGIS users using the ArcGIS Bridge to include the spatial, to include the data science and the statistical capabilities of R within the ArcGIS environment and add that to the spatial analysis and visualization that they're doing within the product, with the ArcGIS Pro product. The bridge also works in the reverse, such that our users are able to use the ArcGIS bridge to bring in a spatial analysis and visualization capabilities into R while they apply their computational statistics. And finally, ArcGIS developers can source from both platforms. So they can source spatial analysis, visualization, and data management capabilities from ArcGIS and grab statistical packages, the thousands of statistical packages that exist in the R programming languages, and come up with a toolbox to provide output that involves both sets of both the strong points of both software. So in that way, even though we probably won't actually have a demo for extending analysis with R, I believe this is something that's just it's good to keep in mind for those of us who have dabbled in R and want to see how you can actually use that within ArcGIS. That sort of analysis can be achieved using the R ArcGIS bridge. Hopefully, in future seminars, we're going to get into it and have a few demos for this particular capability. So having said that, I'd like to thank you for having joined me for this webinar. It's been a bit long and we've jumped in and out of scenarios, and maybe we haven't shown exactly the tools that you wanted us to showcase. But I believe that in future seminars, we're going to get into, not seminars, webinars, we're going to get into these capabilities. And yeah, please feel free to comment on the video and definitely tell us what we missed or what you feel like we'd like to see in future webinars. Thank you very much for joining us. This has been Laban Dungo for Esri Eastern Africa. Have a great evening, day, or afternoon. Thank you.